23 and just like
Okay, so anybody else have any questions on page 127?
Let me see.
So starting with 25?
yeah.
Okay. So starting with 25. Okay, so f of x equals... Yes, it is. Oh, did I say 127? It's 117. I'm sorry.
Oh, 117.
Yes.
Oh, piecewise. What?
I actually accidentally. Never mind.
Don't.
It's bad. He gets sarcastic.
He's not me. What? He's not good at cards.
No, I'm the artist. He's the more than that person. He's like a computer.
Okay, I had to do like 21, 23, and 25 over so many times because I didn't understand that like it was just really
I
frustrating.
did 23, but
Okay.
he goes after that.
So here we go with 25. So all you need to do is graph the function. So looking here, our function changes. There's going to be a discontinuity at x equals 4. So where does x equal 4? 1, 2, 3, 4, right here. So when x is less than or equal to 4, it's 3x minus 14. Okay? Dang it.
What?
Well, 14 is just a big number, and I didn't draw my graph big enough. So let's make each one of these worth 2. So here's 4 right now, because my scale is that each notch is 2. Okay, so right here, 2, 4, 6, 8, 10, 12, 14, because that's my intercept. And then my slope is going to be 3. So up 1, that's 2, and then 3, and over 1. Counting out 3, but all my notches are in 2s.
Oh, right.
So, okay. And then I'm going to draw my line, but I'm going to stop at 4. And draw my arrow that it continues on forever in that direction. And I fill in this dot because I know that x can be equal to 4.
Oh, I get it.
Yay!
I don't know why I didn't get it. I probably just. I don't know.
No, it's new stuff. That's fine. And then when you have x being greater than 4, the function is x, or negative 2x plus 6. So 6 would have been here, or is there, but, and then we would have down 2 over 1, down 2 over 1, and then down 2 over 1, down 2 over 1. So I know it's going to start right here, and then go, see, this way. So down 2 over 1, so then it's going to go like that. Thank you, Isabel. Does that make sense?
I get it.
Yay!
Could I take this home and redo it?
Yeah. Absolutely.
Oh, could you go over one of the piecewise?
What?
Oh, wait, no, never mind.
Because the slope is negative, so it's going to point down. Okay.
Could you go over one of the piecewise too?
Yeah, this is a piecewise function.
Oh, why wouldn't I know that? Okay, I'm fine. I'm fine.
Do you mean like one of the step functions?
Yeah.
Okay. Which one?
I'm not gonna click out. Did you do 36?
36?
Or 35, because 36 isn't one of them.
Well, 35 isn't a step function. Do you want me to do one of these?
Yeah, one of those.
Okay, so let's do 42.
42.
So, 42. F of x is equal to 2 times the greatest integer, x. Cool. Okay. So I never remember which side is open on my greatest integer function, so I'm just going to graph it really quickly.
Wait, 42?
Mm-hmm. We are. I'm just doing an example. So to graph my integer function, I'm going to hit in my y equals. Let's see. I got to find it. So in my y equals menu, I hit math, and then I scroll over to number, and then number 5 is the integer function. So x, and then I'm just going to insert my 2 in front of it, like that. And then, see, is there glare? Yeah, there's glare. Okay. Oh. I need to turn my stat plot off.
Do I need this in
It depends.
Turns out I have 3 years from math instead of 2.
You'll need this for this year and next year.
Because you need that in your life. You need it. Have you ever seen like the little comic strips for it? Or like the videos? They're pretty cute.
That's like one of those dad hats. Just right in the middle.
That's great.
It looks like some kind of retro video game.
Okay. Okay. So this special symbol right here means the greatest integer function. What that means is that y is equal to that entire value of x, but only as an integer. As soon as you would start to get up to the point where you would move into your next x, y jumps up to the next integer. So it doesn't create a diagonal line. It creates horizontal lines that are in pieces, signifying that y can only be an integer. Does that make sense? Yeah? Good. Okay. So if the f of x, which is our y value, is 2 times this, we know that when y is 0, or when x is 0, y is just going to be 0 up until I hit 1. Because as soon as I hit 1, x equals 1, then it jumps up to my y equals 1. And y is going to be 1 the entire time that x is 1 until it gets to 2, when it jumps up to here. Does this make sense? But because I have this 2 in front of it, I know that means that it's going to be stretched vertically. So instead of jumping up 1, it's going to jump up 2. It'll be right here. And then 1, 2. It'll be right there. And then from here, jump down 1, 2. Extend this way. And then 1, 2. Open circle. Like that. Does that make sense? Okay. Does anybody have any more questions about step functions?
This might be one.
Which one?
Number 51 on page 119.
Okay.
They want us to identify the domain and range. I don't have any idea how to do that.
So for the domain, what is the lowest value x can be? Because your domain is given by all of these little constraints about x.
11.75?
That's
Or
y.
0.
0.
Okay. So
This is number 51.
X is between 0
And
8.
80. Yes, so that's your domain. And then what about your y values? What can your y values be?
The 11.75 and the 15.5. stuff.
Yes.
Okay, so you just match all of those to the lowest number of x?
Well, for your range, you just list what your possible y values are. So you just have to list out these numbers.
Oh.
For your domain, you list out what the possible x values are. So you would just write 0 is less than at x, which is less than or equal to 80. Does that make sense? Any other questions?
My brother's sick. I'm trying to not like some weird
My brother brought home a cold last week, so
Same. I'm so happy I didn't get sick.
I heard that flu season came early this year.
Yeah.
But that's going around.
Oh. Brian is going to be here with our delivery in 10 minutes.
Brian?
Brian. He's in a Toyota Corolla. Be prepared to meet Brian outside.
What's Brian doing with his life? Driving around people's food.
Catch me outside. Okay. So.
I was like, just do it. It's all about. Yeah, he just all about.
Oh, that's great.
So, any other questions in the homework?
All of them.
All of them? Any others?
I have no idea.
Any specifically?
No, just all of them.
Well, we just did 51. Did that make sense?
These ones.
Those ones?
Story ones.
Okay. So, on page 127. Okay. We're on page 127. I'm not sure which number yet. Let's see. So this is going to be.
I know.
Well, we're next to the kitchen, so.
Not me.
Okay. So let's do 47. How's that? 47? Good? Okay. Oh, I have vinegar in my bag.
You have vinegar in your bag?
Yeah.
No wonder I kept smelling it.
Oh, we're blowing up Pompeii in my history class. So, I have a volcano. I brought a bunch of Legos. We're gonna build Pompeii. And then I have a volcano and baking soda and vinegar. We're gonna blow it
That's
up.
why I kept smelling it. I was like, it smells rotten.
Okay. I'm gonna start a new policy.
Yes.
These
Oh yeah, I did the whole like where you
are percentage points.
Yeah, it's me.
You can use these on your assignments, on your homework, that's fine, or on your tests, or quizzes. You can use these anytime that you want for anything that's graded in this class. So, I'm going to pass these out if you do good things in class, like not chatting and like participating. Good?
So if you're quiet, if somebody's quiet, will you catch a bunch of people like chatting when you're trying to talk?
Yeah, I'll give one out. These are just totally discretionary. This is not a democracy. This is like a dictatorship where everything that I say happens.
Like, you wait to see how you did, so, like, if you think you did okay on a test, and you end up doing really bad.
Yeah, you don't have to turn it in at the time of the test.
Okay.
Yes, you can turn these in at any time that you want to. And they say 1 point. Yahoo! Huzzah!
Like 1 percentage point.
1 percentage point.
Okay.
So if you got an 89 on the test, but you want to get an A,
90.
make sense? Cool. Okay, so everybody gets one to begin with.
Wait, there was myself and one other person who each already got one from like 2 classes ago, right?
So yeah, you can use that. Okay. So number 47. Let's check on Brian's status. Meet Brian outside in 6 minutes. Catch you outside.
Please no.
My husband made me listen to that remix this weekend. He loves it.
There's like a million remixes.
I don't know which one it is.
She wrote songs?
She didn't write it.
Of course she
It's so
has
auto-tuned.
songs. Of course she has songs.
Oh gosh.
She's
Why
like 14
wouldn't
and
you?
she's singing about things that, like,
And like she's
no one
wearing
should be
like a
singing about.
shirt that shows her belly.
For donut stomachs.
Yeah.
Hey Jacob, here you go.
Okay. You guys,
Okay, so 47. You were sitting in a boat on a lake. Okay.
I'm not very.
Choppy. You can get a sunburn from sunlight that hits you directly and from sunlight that reflects off the water. Sunlight reflects off the water at the point 2, 0. So at this point, okay, and hits you at the point 3.53. So 1, 2, 3.5, 1, 2, 3. So we know that this point is on our graph, and this point is where it gets reflected. So that means that's where it takes a big whoop. That's our vertex. Does this make sense? Just so far. Samantha? Is that okay? Okay. Okay. Oh, I'm not going to. We're not done. Write and graph the function that shows the path of the sunlight. So, y equals a times the absolute value of x minus h plus k is the basic form for our absolute functions, right? Yeah. We can assume that a is 1 since they didn't tell us otherwise. So far, a is 1. We don't have to put a. We know that our vertex is at 2, 0. So this is my h and this is my k. Everybody good? So, x minus h. 2. I would do plus k, but I don't need to. This is good? Because k is 0. So I don't need to write plus 0. But actually, scratch what I said about a not being 1, because we don't know what a is. We need to find it. So, a is still there. So, how are we going to find it? Well, we have 3 things we don't know. Y, a, x. But this point is 3.5, 3. So I do know a y and an x. Yay! It's solvable! So my y is 3. 3 equals a times the absolute value. My x is 3.5. 3.5 minus 2. What's 3.5 minus 2? Yeah! So 3 equals 1.5a. Divide both sides by 1.5. And my a is 2. Checking on Brian. Brian should be here in 3 minutes. Does anybody want to meet Brian outside?
No, what if he's a serial killer?
You want to? Okay. Here you go, Jake.
The minute she says it.
Okay, so Brian is in a Toyota Corolla, and he's pulling into the parking lot right now. It doesn't say what color. Yeah, it's already paid for.
It's nice down you, buddy.
This will be fun. Maybe
See you in the afterlife.
That's incredibly accurate as far as like where Brian is.
Is he in the parking lot?
Oh my
He
gosh,
is
those
now.
things are so scary accurate.
Yeah.
It's like 3
Okay.
foot radius.
Wow. That's creepy. The Illuminati, man.
If
Okay.
you just like sit with Find My Friends on, it's kind of scary.
I don't like that. Okay. See, I don't like that it's called Find My Friends. I think it should be called Find My Most Intimate Loved Ones, with whom I would give power of attorney, and no one else. Like, I have this casual acquaintance. She's a little too
Acquaintancy.
assumption-y. I barely know her. I know her first name and her last name. And she texted me and she said, "Will you be the emergency contact for my kids?" Okay. I did not know how many kids she had. I don't know their names. I've seen them, but they were doing things like and running around, so we didn't like bond, go close. But I didn't want to be rude, so I was like, okay, sure.
No, you should have been truthful.
So, and then she requested to know my location and find my friends. So I'm like, no, pal, back up. I'm drawing the line. You do not get to track, but I know where she is at all times because now she's in my Find My Friends. I don't care.
Now you can avoid her.
Okay. So my function then is y equals 2 times the absolute value of x minus 2. Because we solved for a.
I just did that.
Yay!
Oh wait, never mind. I did 1x minus 2, not 2x minus 2.
Hello? Hang on. I'm putting you on speaker. Hello?
Hi.
Is this Brian?
Yes, it is.
Hi. I'm a teacher
Hi.
here, and my student Jacob is outside looking for you.
Okay. What's the best place, or where's the best place to park?
You can park anywhere, but if you can like walk out kind of by the playground, there should be some glass doors.
Okay.
And then that's probably where Jacob's looking for you.
Okay. And is it closer to the street or farther from the street when you're walking in? Just because I don't know where I am. That's all.
Well, there's only one main entrance to the church. And when you pull in off of Pursuit, you have to, like, you go all the way down and then you make a left. And there's parking there. Are you there?
Okay.
And then you should see the playground from there.
Is there little kids there, or?
Probably.
Only one lane entrance.
Are you finding it?
Is there a basketball court?
What?
Is there a
No,
basketball
go
court?
past that. This is the other school.
Are you at St. Mary's or at the community church? Coast Hills Community.
I'm not sure. It's just, it doesn't say. There's a beige building.
I think you're at the other church. Yeah, we're right next door. I'm trying to look up where you are.
There's number 5?
Yeah, we're at 5. We're 5 Pursuit.
Oh. Okay.
Do you see the glass doors?
The glass doors right here.
What?
I think I found the glass doors right.
Well, there should be a bunch of people out there.
There we go. Let me see.
And when you're facing the glass doors, the playground should be to your left.
It is not. Yeah. Thank you so much. Thank you.
Oh, that was Jacob. Okay. Thanks so much, Brian.
Thank you.
Okay, bye.
Yay.
Okay. So,
I have that job.
move over 1 and up 2. Over 1 and up 2 to graph because I know that my vertical stretch is 2. And then I just graph like this. And that's it.
I think I'm just gonna give up and be the pizza guy.
No, what? No, does this make sense?
No, it does not.
Okay. Seriously, is he calling back?
Yes.
What does he want?
This kid's trying to get in my car.
Hello?
Take me anywhere.
Hello?
Hey, sorry, I didn't mean to hang up on you that quick.
Oh, no, that's okay. No, that's okay.
But, thank you.
Thank you. Okay,
Appreciate it.
have a good one.
Take care.
You too. Okay, bye.
He was like all the way on the other side.
Thanks, Chick. He called. He was on the phone with us when you walked out there.
Oh, okay. Gotcha.
Woohoo! They gave us these carrots and onions.
Like a picture with the back of
Okay.
Right?
Whoa! Look at that. Okay.
Wow, that's nice.
Here are your extras. Limes. Salsa.
Really cool. It was just like right after we walked out, and there was like no one in there. Like, okay. And then I walked to the left, and then he was over there.
We gotta
Okay.
have somebody like
So,
really overreact with the food.
Are you serious? Took you that long?
okay, so back to this. Okay. Do you want me to do this again?
That's okay.
Are you sure?
What is what?
Did they put a spoon?
Okay.
Because I don't know if I'm supposed to.
Can you stay for lunch today, and then I can go over it with you? Okay. I ordered
Chicken. That's beef. That's chicken.
I ordered chicken, beef, and carnitas. I ordered
I
3.
had
Well,
Okay. Any other homework questions before we get into the new material?
That's pretty
four, I think.
Yes.
Carnitas?
These
I'm
three
getting
are chicken.
Yes,
Those
carnitas
three
is
are
pork.
chicken,
I told you
and
guys
those
it was
three are-
chicken. Wait,
Did anyone order
it doesn't look
carne
like
asada?
chicken. Are
Oh,
you sure?
these, that looks like carne
That
asada, and
one's
those are
mine.
carnitas.
She ordered 1 carne asada. I ordered 1 carne asada, 1 carnitas, and 1 chicken. And Isabel got 2 chicken.
I'm gonna
These
do
are
$4.
mine.
Okay.
I'm gonna do the $4 ones.
Okay.
I'm gonna bring my wallet.
Okay.
All the time.
What am I supposed to do with all this?
Because
I'm gonna get some.
I'm thinking this one's gonna be regular.
Yeah, there's no napkins in here.
And they didn't even
Okay.
put. How am I supposed to?
I actually have a fork if you want it. Here you go.
Saturday I fell asleep with my eyes
That
open.
precision though.
Oh,
Yeah.
that's creepy.
My mom walked
Okay.
Did they
So-
try out?
Any other homework questions before we move into the new material?
All the piecewise.
Do you understand them after we went over the example?
Kind of like.
My
Yeah,
friends
yeah,
Okay, so a piecewise function is a combination of different functions, but it limits the function to be specifically within those x values. So it tells you when your x is from here to here, this is what your y value is. Does that make sense? So if you wanted to like use a dotted line to just graph each whole function and then go through and find out where your x is limited to and then erase the rest of it, that might be easier.
See how I did this.
Okay. Do you guys want an extension as a class on the homeworks due date? Yeah. Okay.
finish in class right now. But, so I might not.
Okay. Well, that's being taken care of. Is there any more homework questions before we start with chapter 3?
I don't know yet.
Thank you. There's limes too if you guys want.
No.
No?
Jeremy.
You have to spread the juice in your eye.
Okay. I'm trying to be extra organized this week as far as class goes and your homework. So,
We're gonna have no homework this week.
no, but I already did all your homework to make sure that you guys, I assign you the correct problems.
Thank you for the fork.
You're welcome. So, yeah. Okay. So let us begin on page 139. This should be still review from Algebra 1. Probably not.
That was all.
Yeah, the piecewise functions and the absolute value functions with the transformations, those were probably new. But everything else should have been some sort of review or just like a deeper picture of things you already knew. Does that make sense?
Yeah.
Does everybody feel that way? Okay. Okay. So, moving into this stuff today. Oh, wait, am I supposed to tip Brian? Is that why he called back to try to be so nice?
Yes. I think so. That's what I was wondering.
When I hang up on you, the good customer service.
Past orders.
Anyway,
How do I
When did
view
it
more?
include it?
It didn't show me.
Yeah.
It didn't give me the opportunity to tip him.
Well, too bad.
Well, he didn't go to the right place.
On Uber, you tip right there, so it's weird.
He was just on like a
Okay.
far side.
So, we're talking about systems of equations. A system is just like the solar system or the nervous system, any other place where we use the word system. It just has to do with a bunch of things that are operating together within a certain criteria, right? So everything in the nervous system is part of the nerves. There are individual nerves, and combined we refer to them just as a system. The solar system is a bunch of planets that revolve around the sun, the solar part. Good? This makes sense? Okay. So a system of equations is just a system where we have more than one equation operating together, existing at the same time. The question about whether or not there's a solution to them has to do with, does this x equal that x, and does this y equal that y? Is there a point at which x and y stand for the exact same thing in both equations? Does that make sense? Yeah. Cool. So, if the x's and the y's are the same when there's a solution, that means it's the same exact point, right? Because it's the same x and the same y. Okay. I just don't want to go too fast and not make sense. I want you guys to get the homework. Okay. So, what that means is that's where they intersect. So if the two lines intersect, that means they have a solution. The system of equations has a solution. Does all this terminology make sense? Yeah, good. Okay. Now logically, if where they intersect is their solution, what happens if they're parallel? How many solutions will that have? None, right. Because they never intersect, because they have the exact same slope. So the lines never come closer together, they never go farther apart. They're always doing the same thing in different places. So, no solutions. Now, if we have two lines that end up stacking right on top of each other, how many solutions are there? Infinite! Yes, because every single x in the one is exactly the same as the x in the other. So they happen at the same time. These two lines are called coincident. Make sense? Okay. Is everybody good so far with the underlying concepts? Yeah. Excellent. Okay. So, let's see. To find the solution for the two equations for the systems, and systems can be made up of any number of equations that you want to, but for right now, we're just going to limit it to two. Okay? Cool. So, to find if there's a solution for the equation, you need to test and see. Is this x the same thing as this x? Is this y the same thing as this y? Well, if they are the same thing, they'll work together in math, right? Yes! So what we're going to do, the first method, is what's called substitution. So we're going to test it out. We're going to find in one equation what x is equal to, or what y is equal to, plug it into the other one for that x or for that y, and then see if it all works. Does that make sense? Okay, if it works, then that does have a solution, and that's it. If it doesn't work, then there's no solution. And when we say works or doesn't work, that means you will get all true math statements all the way through, or you won't. Good? Good. Yay! People seem less happy than normal today.
I'm just tired.
Is that one of our phones?
No.
Okay. So, I'm going to do example 12, number 12. Check whether the ordered pair is a solution of the system. Okay, so,
Example.
no, I'm going to do number 12. I'm not going to do, I don't think, the examples anymore, just in case the examples that are in the book are easier than the actual homework problems. So I'm just going to do homework problems for you guys. Not probably part of your homework. It's probably going to be like one of the evens or something. But that way,
We know
yes.
what happened.
Exactly.
Because I have to go back to look at the example because I forget by the time I do my homework.
Well, you can also go online for the Monday class and rewatch it if you want to,
Oh.
because it's recorded.
Okay.
Okay. So, number 12 says, check whether the point 30, oh, what a pretty blue, is a solution of the equation negative x plus 2y equals 3, and the equation 10x plus y equals 30. So, here are my two equations. Together they make a system. I need to see, in order for it to be a solution of the system, it needs to work in both. Does that make sense? Because the x has to be the same x as in the other one. The y has to be the same y as in the other one. So, I'm going to start with this one. Let's label this equation 1 and this equation 2. Does that make sense? Okay. Everybody's following? I'm not moving too fast? Are you okay? Okay.
Well, it doesn't work in equation 1.
Well, I'm going to, okay.
Yeah, sorry, I just
So,
picked that up. I was like, wait, that's not supposed to.
my x is 3, so I have negative 3 plus 2y, so my y is 0, equals 3. So simplifying this down, negative 3, 2 times 0 is 0, so that's just gone, equals 3. Does it? No. So, this is not a solution. Yay! How you guys feel? Okay?
So you just write one not a solution.
You don't even need to worry about it because it's asking if it's a solution of the system. So in order for it to be a solution of the whole system, it has to work in both.
It
So-
works in the second one, right?
So 30 equals 30, yeah. But it doesn't work in the first. So it is not a solution
It's
of...
not a solution because they're in a system.
Point! You're welcome.
You have to problem
Huh?
You have to problem solve the homework.
Yes, you do.
It's math because I have to
Yes. Yeah. Okay, any other questions about number 12? You guys okay with it?
The chocolate is going cold.
The chocolate's getting cold?
The chocolate.
Oh, I know, but I don't want to eat them while I'm supposed to be teaching. I'll wait. Thank you. That was very considerate. Okay, so then number 26, because I'm going to give you stuff from 11 through 19 is identical in method to number 12. So number 26 says, let's do pink. I want to do pink. Pink! Like my bracelet. Okay. 26 says negative x plus 3y. Number 26. Negative x plus 3y equals 8. And I was looking at 20. Thank you. Okay, 26. I'm going to put my finger there so I don't mess up. And then 2x minus 6y equals negative 6. Okay. So when we're working with systems, there are 3 ways to test and see if something is a solution. I already talked about the substitution method, but we're not going to actually have that in your homework for tonight. That's going to be on Wednesday. So, if there's a solution and you're looking at the graph, how can you tell? What does the graph look like at the solution? Yes, it's where they intersect. Yes. Yeah. Everybody gets it? Good? Okay. It does kind of sound like the phone's in here, doesn't it? I wonder if it's in this backpack that's in the corner.
This
Cool.
may not be able to, like,
You can use them on your final, your midterm. I don't care.
Save them all for the final.
Good.
what's the percentage grading in this class? It's like the final, like, 50 or 60%. Like, it is.
No, it's on your syllabus.
I'm guessing it's like 20 to 30.
Okay. So, gonna solve for y. So we're gonna start with, here's equation 1, here's equation 2. So equation 1, negative x plus 3y equals 3. So to solve for y, I'm just gonna move everything that's with y to the other side. So because this is negative x, add x. So 3y equals x plus 3. Y is still not by itself because it's being multiplied by 3. So I'm going to unmultiply by 3, which means divide.
These are fun.
We're going to graph them. Right.
Mm-hmm.
So I'm going to solve it for y so that it can be in y equals mx plus b form, which is the easiest form to graph from. Does make sense? Okay. So these cancel out. I'm left with y equals, and then it's x plus 3 divided by 3, so I can actually use the distributive property and divide each one by 3 separately. Does that make sense? Okay. So instead of writing it as x divided by 3, I want to write it as a coefficient of x so I can see what my m is. Because in slope-intercept form, it's y equals mx plus b. So x divided by 3 is the same thing as 1/3 times x. And then what's 3 divided by 3? Nice job, Samantha! Guys like the points? Yeah? Cool. Cool. 1. Does everybody follow so far? Excellent. So this is the same thing as y equals 1/3 x plus 1. Okay, now I'm going to do the second one. Does anybody still need to copy this down? I'm going to erase it.
So that's like the final.
That's just this exact equation with written in y equals mx plus p form. Okay. They should make taco-scented candles, right? Tori agrees with me.
Right. It would smell like grease and like onions and cilantro, and I don't smell that.
I think it smells good right now.
Wait, what did you say?
I think it smells good right now. Okay.
That's okay.
So here's my second equation. I'm just going to do the same thing. Solve for y. So move my x to the other side, and I get negative 6y equals negative 2x minus 6. Dividing by negative 6 to isolate y, I get that y equals, now here, negative 2 divided by negative 6 is positive 1/3. Good? X, and then what's negative 6 divided by negative 6? 1 plus 1. What?
And then they have.
So, now that I know my equations, I'm going to graph them. Yes, sir, Justin.
The point being that if you have a system of equations that has a solution, or that has a solution, that they're actually going to be the same equation if you work a little bit of algebra.
No.
Or
We are putting both of these equations into y equals mx plus b form so that we can graph them and see where they have the same point.
Oh,
Yes.
which would be
Yeah, they have all the same
all the
points,
same
right?
points.
So it's going to be an infinite number of solutions.
Cool.
If there were only one solution, then when we graph them, they would just intersect. There are only 3 options. They don't intersect, which means they're parallel, and there's no solution for that. they do intersect, which means they're not parallel, and there's one point in common, so one solution. Or they're called coincident, which means they are right on top of each other, and then they have infinite solutions.
What about if it's like a wrap?
Well, there are more possibilities for that, but because parabolas curve, that's why there are more possibilities for that.
Okay.
And that's going to be explored more in probably pre-calculus, but I think there might be more of it this year. So, but for now, because we're only dealing with lines, there are only those 3 possibilities. Because lines can't bend, lines can't curve. Good? Yeah, this isn't so bad, right?
Actually, what if it's like a piecewise?
You probably will not have systems of piecewise functions. If you do, I will walk you through it really, really slowly and repetitively. Okay. So, oh, I thought I picked up black. So to graph it, find my y-intercept, which is just 1. I'm going to use blue. And then 1/3 is my slope, so up 1 over 3, 1, 2, 3, and connect. That's awful. There we go, that's a little bit better.
So just up 1 over 3.
Mm-hmm. Remember, slope is the change in y over the change in x. So rise over run. And then if I were to graph my second one, I would just do exactly the same thing. Oh, 1, up 1 over 3, oh, connect. And then I would write infinite solutions. Awesome. Awesome. How's everybody feeling? Good? Good? Cool. Okay, so let's do another one. Let's do number 34. Does anybody need to copy this down, or has everybody got it? So, number 34. I'm just going to rudimentarily copy this graph out because I expect this one to be fairly easy. The question asks, how many solutions does this system have? 1! Explain your reasoning. It intersects once, so there's only one point at which these lines have the exact same x and y that work in it. Right? It's the x and y that they have in common that makes it the solution. Because both of them have infinite possibilities in x and y pairs. There's only one point where they're the same in this case. And that's all you have to do for that one. Yay! I'm sleepy. I spent a lot of time doing this stuff over the weekend and then preparing my projects for my history classes. I'm sleepy. I hope they like building Pompeii. I'm kind of nervous.
I'm sure they will.
I hope so.
How old are they?
Your brother's age. It's your brother's class.
And they'll love blowing.
Legos. Need to look stuff up. So.
Yeah, and it's the volcano from Star Wars. Because
And they'll love it.
I'm a 30-something-year-old infant, apparently. Right. I'm into the same stuff as children. You're cool. We go to the same movies. I don't watch rated R movies. You play with the same toys. Cool. Okay. Any questions about the problems like 34?
No.
Okay. So let's do number 42. Yes. So 7x plus y equals 10. And 3x minus 2y equals negative 3. So what's my first step? Yeah. Solve for y. Okay. So, looking at equation 1 of 2. 1 says 7x plus y. I like to write in cursive. Equals 10. So get y by itself. Move my x. And y equals negative 7x plus 10. So I'm going to write that up here. And then equation 2. 3x minus 2y equals negative 3. Gonna get y by itself by moving my x's. And I get negative 2y equals negative 3x minus 3. Not a very positive equation. Glass is half empty to this guy. Negative 2y equals negative 3x minus 3. Oh, yeah, I referred to the equation as a guy. Okay. Pink can be... John Wayne wore a lot of pink.
But it started off in like the 1800s. Really, it was like a masculine color.
Huh.
Did you not know that?
Well, I know that most trends that we look at and consider feminine actually started off as a male fashion.
Yeah.
Like high heels, ruffles, makeup was started with Cleopatra, so actually not that one.
Yeah,
But
Egyptians men wore eyeliner too, so.
Yeah.
You guys can do it.
Perfume. Started off with men.
Now it's called cologne. Cologne.
It still smells good. So
Okay. So dividing everything by negative 2, I get that y equals 3 halves x plus 3 halves. So y equals 3 halves x plus 3 halves. What? Oh, it's totally a function. That's fine. It's totally a system. Right. A system is just multiple equations at the same time that we identify as a system. We are testing to see where there's a solution. If there are 3 possibilities. No solutions, which means they're parallel. 1 solution, which means they intersect. Or infinite number of solutions, which means that they're like the same equation. Does that make sense? Okay. No. Right. Still a system.
Wait, so can you have like a system of functions?
That's what we have.
Oh, right. So like, no, a function, a system of 2 relations. So let's
Sure.
say we had 2 of the curves.
Mm-hmm.
Then you would have 2 solutions, right? Because if the curves intersected.
Well, there are a lot more possibilities if the lines are not lines anymore, but they're curving.
Yeah.
So, right. We are only pretty much going to be studying functions in this class. which is just when x is the independent variable, because there's a lot of characteristics that we can just take advantage of. It makes it a lot easier to compare things and understand what's going on in them. So we're exploring functions. But at a certain point, whether or not it's a function is interesting, but is not necessary for the math and for what you're doing. Does that make sense?
Wait, so have we figured out, does this have any?
We haven't graphed it yet. Okay, so now we're going to graph it. Okay, here are my axes. Okay, so equation 1 says y equals negative 7x plus 10. So here's my b, here's my m. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's my intercept. My slope is negative 7. So I'm going to go down 7 and then over 1 positive x. So 1, 2, 3, 4, 5, 6, 7, and over 1. Then I'm going to connect my dots. Like so. Let's use green. Green's a good color to do equation 2. So, okay, y equals 3 half x. 3 halves x plus 3 halves. So 3 halves is right here. Because it's 1 half, 2 halves, 3 halves. And then I'm going to go up 3 and over 2. So 1, 2, 3. 1, 2. And then I'm just going to connect. Is there a solution? And if so, how many? Yes! There's a 1! So what is it? Well, let's see. Looks like it's right there. So that looks like it's 2, 3. Let's test it out.
Okay, so do we have to say what the solution is?
Well, I think for this part, this says if there is exactly one solution, estimate the solution and check it out algebraically. So for these particular problems right here, you're going to guess what it is based on what it looks like, and then test it in your equations to see if it works. Okay? So, let's plug this 2, 3 into our first one. 7. 7x plus y equals 10. So 7 times 2 plus 3. Let's actually guess it's 1, 3. Let's do that. Let's guess it's 1, 3, because I think it looks closer to the 1. 1. 7 times 1 plus 3 equals 10. Does that work? Yeah. Check. Okay. And then we've got 3x, so 3 times 1, minus 2y, so minus 2 times 3, equals negative 3. So 3 minus 2 times 3 is 6, equals negative 3. Does this work? Yes! Check! That's my solution. This is seriously nothing compared to what's coming at the end of the year. Where do we start doing conics? Super fun. Yeah. Conics? Conic functions? It's pretty much, so the idea of a conic is that if you have two cones that are stacked on top of each other, and a plane intersects them,
Yeah, it's one of those tiny things.
there are three,
Oh my gosh.
four possible ways that this plane can intersect. So, it can intersect at a hyperbola, a circle, an ellipse, or a parabola. So we're going to do that later. And those are all relations. Except for the parabola. There's one possible parabola that is a function. Everything else is relations. Yeah, if it's up and down. Come on inside. But if you get to pre-calculus, then we actually start doing things like rotating the axes of the conics.
On paper, not on like a computer.
Right. And then in calculus, you rotate it all the way and find the volume of the figure that is created. Yes.
Why?
Because why not? This is math. We're understanding the world around us.
Have you guys ever seen that joke about why algebra 165 is X? I don't know, I've seen it somewhere, it made me laugh.
I like math jokes. Okay. Does anybody have any questions about 42? Does it make sense to everyone present?
Yes.
Excellent.
This is small print.
Good.
I can work off of this.
Yeah, just ignore the conic stuff. Take full advantage of not having to know that yet. Okay. So, 52. We're going to do number 52. It's the same type of thing. 3/4 x plus y equals 5. And 3x plus 4y, 52. 3x plus 4y equals 2. So, move my x from this one by subtracting it from both sides, and I get that y equals negative 3/4 x plus 5. Here, moving my 3x, I get that 4y equals negative 3x plus 2. Divide everything by 4. And I get that y equals negative 3/4 x plus 2. Nope, it's 1/2. Thank you. You were right. 2 divided by 4 is not 2. It's 1/2. You're welcome. If I make a mistake, please correct me. I don't want to do it wrong. And you guys are trying to learn from this. That'd be awful if it was wrong. Okay. So 3/4 x, negative 3/4 x plus 1/2. Yeah, totally correct me if I do something wrong. That's a good thing. Okay? Okay. So, to graph it, I'm sleepy. Excuse me. Okay. Equation 1. Y equals negative 3/4 x plus 5. Plus 5. Down 3. 1, 2, 3. Over 4. 1, 2, 3, 4. Connect. Graph 2. Y equals... What? Y equals negative 3/4 x plus 1/2. 1/2. Down 3. 1, 2, 3. Over 4. 1, 2, 3, 4. Now, pretend these are straight lines. How many solutions do I have? No solution. And that's the problem. No solution. Thank you, Joss. Okay. Not so bad, right? One more problem. Yes. 58. Okay. So 58 is a word problem. You don't have very many of those for your homework tonight, but your word problems ask you to use a verbal model. Feel free to not do that.
What's a verbal model?
There's an example for you in number 54.
Oh.
Yeah, that it's just writing out like everything that it says. So
That's annoying.
you can do that if you want to, but you are not required. The instructions say use a verbal model, so I wanted to clarify in class. You do not have to do that. You can do it. Did you ask if you'll get extra credit? No. Okay. So 58 says, your portable stereo requires 10 size D batteries. You have $25 to spend. 25 on 5 packages of 2 batteries each, and would like to maximize your battery power. Each regular package of batteries costs $4.25 each. Regular. You're welcome. Okay. And each alkaline package of batteries costs $5.50. This is number 58, Jocelyn. Okay. How many packages of each type of battery should you buy? Well, let's make X our regular and Y our alkaline. And this is number of packages. So what is X plus Y? How many packages are we buying? What's it say? 5. X plus Y equals 5. And how much are we going to spend on regular? We're going to spend $4.25 on each one. So to figure out how much we spend on regular total, it's $4.25 X. 425X. How much are we going to spend on our alkaline? 550Y. Let's just do 5.5Y. And when we add those together, how much are we going to spend total? 25. For the word problems, I encourage you to solve these using a graphing calculator. Or Desmos. So, to input this into your graphing calculator, which is how I'm going to solve it, you just have to put it in y equals form. X plus y equals 5, so subtract x from each side, and I get that y equals negative x plus 5. Subtract x from both sides over here. And I get that 5.5y equals negative 4.25x plus 25 and then divide by 5.5. 5.5 cancels. So y equals, and because you're going to put this into your calculator, you don't even need to simplify it. Negative 4.25 over 5.5 x plus 25 over 5.5. So, go into your calculators. Oh, that's okay. Oh, thank you. Thank you, Kirsten. Turn it on. Who would like to use my other one? I don't think you have a graphing calculator yet. Anybody want to use my other one? I have two. Okay. So, calculator's on. You go to y equals, and it's just going to have a bunch of different y's, and then they equal stuff, and this is where you put your equation in. And this is why you need to solve it for y first, because it already has the y here, you can't change that. So you just need to type in what y equals. So, for our first equation, y equals negative x plus 5. So if you hit the minus instead of the negative, it'll come back with an error. So the negative is right next to the 0 and the decimal. So negative x plus 5. And then just press enter to move down to the next one. We got that y equals negative, and then in parentheses, we have 4.25 divided by 5.5. And then okay.
11:40.
So we're almost done. If you want to. Okay, so we only have like 2 or 3 more minutes. Okay. So negative 4.25 divided by 5.5x, and then plus, and then in parentheses 25 divided by 5.5. Press enter. And then I'm going to adjust my window by pushing window. It just tells me telling the calculator what part of the graph I want to see. Make sense? Okay. So I'm going to go from negative 10 to 10 for both my x and y.
I always just use Zoom.
You can do that if you want to.
I don't know how the window stuff works. It just looked really complicated, so.
It's not that bad. So I can teach you if you'd like. But, or you can use Zoom.
Wait, so do we have to buy a graphing calculator, or can we just use Desmos?
You can use Desmos, but for
That looks so much nicer than mine.
I recommend that you have a graphing calculator.
Does it make that much of a difference?
It makes a pretty big difference because Desmos doesn't do a lot of stuff. Desmos graphs. Desmos does not do matrices. It does not fit data to a model.
So are we going to need that stuff for this class?
How much is the C?
Is this one?
Yeah.
It's like $100. So, okay. And then to find exactly what that point is where they intersect, I'm going to hit my second button. And then above trace, it says calc. So second trace, which is calc. And I want it to find where they intersect. So that's command number 5. So 5. Then it says first curve. And it's going to be blinking on one of the graphs. So yes, enter. Second curve. And then I'll hit yes. And then it will ask if I want it to guess. It's a very complicated reason why it's guessing and not calculating. I can explain it for you if you want to, but I don't want to confuse you guys, so then you just press enter. And it tells me that they intersect at the point 2, 3. And that's the answer. Does that make sense? Does anybody have any questions? Okay, so I'll give you your homework assignment and that's it. What? Seriously.
It will keep getting faster.
Okay. So you have 3-1. Page 142, 11 through 21 odd, 25 through 33 every other odd, 35 through 41 odd, 45, 49, and 53 through 57 odd. There were some problems that I didn't want you to do because I thought they were kind of dumb. So that's why your homework kind of skips around. That's it.
Wait, so it all is contained within, like, starting at page 142?
Yes.
It's all in that section of homework?
Yes.
That's nice.
2 hours. I think 2 hours.
Good. Yeah. If you guys have your homework, I'll collect it. And then the extension, yeah. You guys have the extension on your homework, so until Wednesday is okay? Okay. So then, do you guys need extra time before I give you your test? Yeah? Okay, so how about I give you your tests on Wednesday to do over the weekend?
That sounds nice.
Okay. Because I don't want you guys to have to take the test on the same day you're still trying to figure out the material. Okay. All right. So that's it.